Good morning. Today we'll discuss composite transformations. We have already seen how composite transformations can be applied in concatenation to perform the reflection of this polygon with respect to the horizontal line y is equal to 2. The next problem is how the same object can be reflected with respect to the vertical line x is equal to 2. So, in this case we have to give transformation so that this line reflector x is equal to 2 coincides with the y axis. So, for this purpose here if this is the Cartesian coordinate system and this is the reflector x is equal to 2. We want to take the reflection of this triangle with respect to this reflector. So, to you have to give transformation so that this reflector coincides with the y axis. So, for that purpose we need to translate this point, say this point is say P, we need to translate P so that P coincides with the origin 0 0. So, here the first step for B, step 1, translate P, the coordinate for P is x is equal to 2 and y is equal to 0. So, translate P 2 0 to origin. So, if I consider this vector is V, that is OP is V. Okay. So, we are calling this translation as T minus V, because we have considered OP is V, which is nothing but 2I. Okay. So, this is the direction of V and we are giving translation opposite to the direction of V. So, that is why T minus V. And we have already discussed that what is the expressions for T minus V. It is very simple now. T minus V, what is that? This is 1 0, here T x is equal to minus 2 0 1, this is 0, because T y, that is y direction translation is 0 and 0 0 1. So, this is the expressions for T minus V. Now, after that this reflector coincides with the y axis. Then step 2, take reflection with respect to y axis, because this is now y axis. Now, that reflection matrix we have already calculated earlier, that is m y. We know the expressions for m y. And step 3, next step, step 3, we have to give inverse of step 1, that is we have to give back translation so that the point which was earlier coincident with origin, that becomes restored to its original position, that is 2 0. So, give inverse translation so that P is restored back to 2 0. So, this is basically inverse of step 1. We are calling this as T minus V inverse, that inverse of step 1. This is nothing but T V. So, this basically this is inverse of step 1. So, we need to apply these three operations, basic operations in sequence. The first operations is step 1. So, that will be operated first. So, if I consider any arbitrary point, on that point first T minus V is applied. On that result, we will apply mirror reflection with respect to y axis, step 2, and then we will apply T V. So, this is your composite transformations matrix M, where the reflector is x is equal to 2. So, this is the composite transformation matrix, and then we will apply this ML M x is equal to 2. Here L is x is equal to 2. So, M x is equal to 2, that will be applied on these 4 points A, B, C, D, and we will get A dash, B dash, C dash, D dash. Okay. So, we can easily express these 3 matrices, and we can get the result after multiplying these 3 matrices. Let us multiply and obtain the result. Okay. So, M x is equal to 2 is T V, which is nothing but this matrix 1 0 2 0 1 0 0 0 1. So, this is T V. Now, what is M y? Reflection with respect to x axis. In this case, reflection with respect to x is equal to 2, that is, in this case the matrix is y component remains same. Okay. So, this is x component is reversed, minus 1 0 0, this is 0 1 0 0 0 1, and what is T V? T V is 1 0 minus 2 0 1 0 0 0 1. So, after multiplying these, we will get the result. Okay. So, this T V is this M y, mirror reflection with respect to y axis, that is given by this matrix operator, and T minus V is given by this matrix. So, when we multiply these two, we will get this one, because this row into this column, that is minus 1, this row into this column, that is 0, this row into this column, that is 2. Then second row, first column, so that value is 0, this. So, multiplying these two, we got this one, minus 1 0 2 0 1 0 0 0 1, and then we are multiplying these with this matrix. So, this becomes minus 1 into 1 minus 1, this into 0 0 into 0 plus 2 into 0. So, minus 1, then this row into this column, that is 0, this row into this column, so that is 2 plus 2, because minus 1 into minus 2, that is 2, then 2 into 1, that is 2, and this row, this column, that is 0 1 0, then last row, first column 0, last row, second column 0, last row, third column, that is 1. So, this is the final matrix operator, okay, where the reflection is taken with respect to the mirror aligned along x is equal to 2. Now, we have to apply this operator onto the object ABCD. Now, let us see what is the result for the transform positions of the points A dash, B dash, C dash, D dash. So, this is the operator matrix, and this is the object points, this is A, B, C, D. So, if you multiply this operator on these points A, so this into this plus this into this plus this into this. So, this is minus 2 plus 4. Similarly, first row, second column, that is 1 plus 4, and third row, that is 4, then minus 3 plus 2, because this into this, that is minus 3 plus 4 into 1, minus 4. Similarly, this row, second row, first column, second row, second column, 0, second row, third column, that is 2, second row, fourth column, that is minus 2, that is 2, and third row, first column, that is 1, third row, second column, 1, and so on. So, the result matrix is, that is 2, 0, 1, second one is 5, 0, 1, 4, 2, 1, and this is 1, 2, 1. So, this is A dash. So, A dash is 2, 0, B dash is 5, 0, C dash is 4, 2, and D dash is 1, 2, 1, 2. So, this is the positions of the object after reflection with respect to x axis. Similarly, in the third case, here the reflector is aligned along y is equal to, so y is equal to x plus 2. So, this is the position of the reflector, y is equal to x plus 2. So, that here the slope m is 1, that means it is aligned with the x axis with 45 degree, because m which is equal to tan theta, which is 1, and it is passing through 0, 2. So, this equation, this point is 0, 2. So, in this case we have to give transformations, like we have already discussed the general equations for reflection with respect to the line y is equal to mx plus c. So, after getting all these operator, we can put the value directly, or we can start with these equations independently, and we can give the required number of transformations, so that this reflector coincides with any of the principal axes, either x axis or y axis. So, here if we want to coincide with the x axis, this is x axis, this is y axis, then we have to give first translation, so that this point, let this is P. So, this P coincides with the origin 0. So, in this case, first step, step 1, that is translate P to origin. So, again we are calling this as T minus V, because what is V here? V is 0 I cap plus 2 j cap. So, this is nothing but 2 j cap, because x component here is 0. Step 2. So, after step 1, these reflectors will be like that. This will be the position of the reflector, the mirror. Now, then we have to give rotation through an angle minus theta. So, we have to give rotations through an angle minus theta, because this is clockwise rotation. So, this is minus theta. We have to give rotation through an angle minus theta with respect to origin. So, step 2, perform rotation through an angle 45 degree. This is clockwise with respect to origin. Let us call this operator as rotation with respect to origin through an angle 45. So, this is minus 45, because this is clockwise rotation. And we know the rotation operator. Just here, there we need to put the value of theta, which is 45. And step 3, after this step 3. So after this rotation, this is coincident with the x-axis. So take the reflection. Take the reflection with respect to x-axis. Take the reflection with respect to x-axis. So that is mirror reflection with respect to x-axis. We know the operator. And step 4, this is the inverse of step 2, because after the reflection we have to restore the original configurations. So we have to first rotate through an angle 45 counterclockwise. So rotate with respect to origin, rotate with respect to origin through an angle, through an angle 45. So this step is inverse of step, okay, inverse of step 2. So we call this operator as rotation R with respect to origin 45. So this is nothing but rotation with respect to origin minus 45, that is inverse. So this operator is also known to us. And step 5, then we have to translate back from origin to 0 2. So translate P from origin to that point, that is 0 2. This is inverse of step 1. This is inverse of step 1. So we call this operator as T V. So again, T V is nothing but the inverse of this step, T minus V inverse. So all these operators are known. So the final reflection operator, that is reflection operator rotation, first we are giving, let us understand the reflection operator.